All right, today we're going to talk about something huge, the hidden code that literally runs our entire universe. I'm talking about the science that connects, the phone in your hand to the most distant stars out there. Let's dive in. Okay, so let's start with something you probably do every single day. You pull out your phone, you open up a map, and bam, there's that little blue dot showing you exactly where you are. I mean, it really does feel like magic, right? But how does it actually work? Well, it's definitely not magic. The answer is this incredible mix of some really, really big ideas. I mean, think about this. For your GPS to work, the satellites whizzing around Earth have to constantly account for Einstein's theory of relativity. If they didn't, your location would be off by miles every single day. And the signals themselves? That's all electromagnetism. The tiny computer chips making sense of it all, they're playing by the super weird rules of quantum mechanics. So you've got relativity, electromagnetism, quantum mechanics. And what do they all have in common? It's one word: physics. Yep, it's the hidden operating system behind, well, pretty much everything in our modern world. All right, so if physics is the operating system for reality, what does that code actually look like? Let's peel back the curtain a little and take a look at the fundamental rules that run the whole show. So, at its very core, what is physics? You can think of it as the ultimate quest for understanding. It's all about asking the big questions, like what are the basic building blocks of, well, everything? That's matter and energy. And what are the rules for the stage they play on? That's space and time. Physics is really just the science of how all of that stuff interacts and connects. And look, this isn't just about super complex formulas on a chalkboard somewhere. Physics actually starts with the simple questions that we've all wondered about. Like, why does an apple fall down instead of up? What in the world is a rainbow, really? Or how can you flip a tiny switch and instantly light up an entire room? Physics is just the tool we've built over centuries to find the real, solid answers to those questions. And you really can't overstate how important it is. Just think about it for a second. Chemistry? That's basically just the physics of how atoms decide to stick together. Biology? That's the physics and the chemistry of life itself. And engineering? That's just people applying the laws of physics to build cool stuff. When you get right down to it, all of these other sciences are standing on the shoulders of physics. Okay, so if physics is the universe's blueprint, what do the different rooms and hallways look like? Let's take a quick tour of reality, shall we? So physics is a huge field, right? But we can break it down into a few main areas. You've got mechanics. That's the study of motion. Everything from a baseball flying through the air to a planet orbiting the sun. Then there's thermodynamics, which is all about heat and energy. Electromagnetism, that governs everything from the light you're seeing right now to the electricity that's powering your device. Optics is a deep dive specifically on light. And then you have modern physics. And that's where things get really weird and interesting. Another way to slice it is to think about two big eras. First, there's classical physics. This is the stuff from guys like Newton. It perfectly describes the world we can see and touch and interact with every day. But then you have modern physics, and this is where we go to the extremes. We're talking about the quantum world of tiny atoms, the crazy speeds of relativity near the speed of light, and the mind-bending gravity of black holes. Two totally different sides of the same coin. Okay, that's enough theory. Let's bring this all back down to Earth. Where do all these big, grand ideas actually show up in our day-to-day lives? Honestly, the answer is absolutely everywhere, from the cosmos right down to your kitchen. Just take a look at modern medicine. The fact that we can see inside the human body without making a single cut, that is pure physics in action. X-rays, MRI scans that use these incredibly powerful magnetic fields, even lasers that are so precise they can perform surgery on your eye. These are all direct applications of physics that are literally saving lives every single day. And that's really just the beginning. The core pillars of our entire society are built on physics. How do we get around? Transportation, cars, planes, that's all aerodynamics and combustion. How are we even talking right now? Communication, the internet, our phones. That depends on satellites and fiber optics. And our energy? Solar panels, nuclear power plants? It's all one massive, incredible application of physics. And seriously, the list just keeps going. Designing buildings that can survive an earthquake? That's physics. Knowing the perfect way to cook a steak using heat transfer? That's physics. Analyzing an athlete's form to squeeze out a little more performance? Yep, physics. Even the simple act of you hearing my voice right now is all about the physics of sound waves traveling through the air. It's inescapable.
So, okay, it's pretty clear that physics is all around us. But why does actually studying it, matter so much for our future? Let's zoom out and look at the really big picture here. To put it simply, physics is our #1 tool for making progress. The biggest challenges we're facing as a species, things like developing clean energy, finding cures for diseases, exploring space, all of it depends on us applying the laws of physics in new and clever ways. It's the engine that drives all of our innovation.
And you know what? That engine of innovation is what powers our modern economy. Physics is the absolute bedrock for at least 7 major industries, from IT and healthcare all the way to aerospace and telecommunications.
And what that means is that the career paths for someone who understands physics are incredibly diverse. I mean, you might picture a physicist in a lab coat, and sure, that's one path. But the problem-solving skills you learn are in super high demand everywhere. You see physics grads becoming data scientists in a high-tech office, aerospace engineers out in the field, and even financial analysts on Wall Street, all because they've been trained to break down really complex problems and find a solution.
So, after all that, after seeing how it works, where we use it, and why it's so important, what's the one crucial point? What's the main takeaway here?
It really comes down to this. Physics isn't just another subject you learn in school. It's the literal operating system of the entire universe. And the better you get at reading that code, the more power you have to analyze your world, to innovate, and to solve the problems that matter. I mean, think about it. Physics has already revealed the secrets of the atom and the secrets of the stars. It's given us this incredible map of reality, from the tiniest particles to the biggest galaxies. The only question left is, what will it reveal next?